Hi folks. Okay, I'm going to make this video here to kind of pick up where we left off last night on the solving quadratics part. Got some stuff going on in the background, so you may hear some construction, and also, whoops, also all I have is the microphone on my computer, so the sound might be a little bit laxed, but it'll get us through this anyway. All right, so let me get about where we need to be here. I remember where we left off. Okay, quadratic formula, that's where we left off. So first of all, let me kind of do a quick overview of the quadratic formula. So any equations in the following form, ax squared plus bx plus c equals 0, where a, b, and c are numbers, has the following solutions. X is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. Now you might be wondering, well, where does that come from? I'm just going to leave that as a separate video, and the purpose of this is just going to be how to use it to solve these problems. Now, the one thing I will mention, though, in your homework, it talks about what's called the discriminant. This part right here is the discriminant. And you'll notice that, let me go backwards and get this stuff out of here. You'll notice it's under that radical. So while I'm here, I'm just going to talk about it right now. If this comes out to be 0, you'll notice there's really only one solution here, minus b over 2a, and it's a real solution. If that thing comes out to be some positive number, then you have two real solutions. And if that thing comes out to be some negative number, then you have an imaginary solution because you have a negative value under the radical. So with those things in mind, let us move on here, and finish our notes here. So this says to solve by the quadratic formula. So comparing this to this, you'll notice that a is 1 because this is, you could think of it as 1x squared. B is 7, right, there's your b, and c is plus 12. Now, usually when I start trying to teach people how to use the quadratic formula, I take the time to write this off to the side, like I've done this time, but from here on out, I won't bother doing that. Then we're just going to write out our solutions. So x is going to equal, right, minus b would be minus 7, plus or minus square root of. Now, if you don't mind, what I'm going to do is this, b squared, right? If you take 7 and square it, that's going to be 49, minus 4 times a times c, all over twice a, 2 times 1. Again, that's b squared right there. And feel free to do this. You know, if you're doing a quiz for me and I'm grading it, I would see that immediately and know what that means. If you want to write 7 squared there, that's fine too. The rest of this now is cosmetic here. We just have to kind of clean things up. So let's take a look under here. So this is going to be 49 minus, if you don't mind, I'll do this. This green product right here is 48. So 49 minus 48 is 1. And the square root of 1 is 1. And there's our two solutions. Now we want to write them one at a time. So negative 7 plus 1 is negative 6 over 2. Right, there's your negative 3. Negative 7 minus 1 is negative 8 over 2, and there's your negative 4, and there is our solution set for that problem. All right, All right, how do I scroll down? Oh, there we go. All right, taking a look at another one here. So now, for this animal, I'm just going to write out the solution at this point. All right, here's your b, negative 7. So the opposite of b would be 7. Plus or minus the square root of, okay, b squared would be 49 minus 4 times a times c. Now be real careful here. Your c is negative 2 all over 2 times a. And again, a is 2. Now we're going to start cleaning this up a little bit. Right, being real careful under here. I'm going to do this in green. So this term right here is positive 16. And 49 and 16, what is that? 49, 59, 69. Let's see, that's going to be square root of 49 plus 16. I guess I'm going to have to write this off to the side here. That's a 5, 1, 6, 65, square root 65. I don't like doing arithmetic anymore. And then 2 times 2 is 4. All right, now 65 does not have a nice even square root, so you just leave it alone. So the two solutions are 7 plus root 65 over 2. Oh, I'm sorry. Oops. That product is 4. And 7 minus root 65 over 4, and there they are. Okay, so this one, I am going to leave it to you folks, right? As you folks, I'm going to put like in class here. That's for you folks to do. And I'd like you to have this one done when we show up on Wednesday, please. Okay, let's talk about this, where it says compute the discriminant and discuss the solutions. So remember, the discriminant was the b squared minus 4ac. So in this particular problem, the discriminant, I'm going to put d for discriminant. Okay, b squared, if you don't mind, I'm just going to put 16, minus 4, a is 1, because although it's not written there, you can think of that as 1x squared, times c is negative 4. So this is going to be 16 plus 16. Now why plus? Because you have a minus there and there, which is 32. Now it's important to note, positive 32. So in the quadratic formula, where you have that, that minus b plus or minus square root of part, this is going to be some positive number. So you're going to get a real value there. So what we're looking at is we're going to have 2 real solutions to this equation if we actually push it through and get numbers out of it. This one doesn't have an answer here, so let's take a look at this one. Right here, so b squared, so I'm going to put d for discriminant equals, right? B squared would be 36 minus 4 times a times c. Now, it doesn't even really matter here what the actual value is, right? This is going to be a negative number, right? Because you have 36 minus 12 times 8 is 96, I believe. So what is that? Negative 60. Right? The minus sign is the super important thing. That means, right, in that quadratic formula, remember where it's opposite of b plus or minus square root of, I'm just going to put d for discriminant, okay? This is a negative number right here. So now what we're going to get is imaginary solutions. We're going to be able to say, all right, square root of negative 1 is I. And now we have 2 imaginary solutions because it's negative b plus or minus something here. So this is going to have, I'll just put our discriminant as negative 60. We're going to have 2 imaginary solutions. And I'm going to go ahead and let you folks please do this one and this one. We will discuss first thing when we come in. All right, so now I'm going to go through 1 or 2 of these. This one I'm going to let you folks do, but I'm going to get you kind of started on it. We can't just set this equal to 0 and this equal to 0 because this is not 0 on the right. Right? Had that been a 0, we could do that, right? But it's not. So distribute this, reorganize it, and then see if you can either 1, factor it to complete the square, or C, apply the quadratic formula. Any of the 3 should yield this. To tell you the truth, when you see solutions like this thing's not going to factor. I would just use the quadratic formula. My advice usually for people is this: get good at the quadratic formula. It never fails, and it always works. Okay. Same thing here. Multiply this out, redistribute it, apply the quadratic formula. This one right here as well. I would just, in fact, this one I'll do. Captain Rod. Solution, all right? Now, the fact that these are y's versus x's does not matter. It's just a variable. Applying the quadratic formula, y is going to equal, right? There's your b, -6. The opposite of that would be 6, plus or minus square root of. Now, -6 squared is 36, minus 4 times 1. Now, you can think of this as 1y squared. And then times c all over twice a. So that's going to be 6 plus or minus square root of. Okay, so this is 100. 36 minus 100 is, what is that? -64, I believe. Over 2. Now, remember, this -64, we can treat that as -1 times 64. So this is 6 plus or minus I times the square root of 64, which is 8 over 2. So this is 3 plus or minus 4i. And there's our two solutions. Now the 4 is coming from 8 over 2, and I just wrote the 4 first. So that's kind of the idea behind how to apply the quadratic formula. Please try to solve these other two here. I'm going to ask you for your solutions when you show up on Wednesday. And anyway, I hope that this video helps. Have a great day.